So here we have a stone is thrown from a 100-meter cliff at an initial speed of 20 meters per second at an angle of 30 degrees from the horizontal. The height of the stone can be modeled by h of t is equal to negative 4.9 t squared plus 10t plus 100, where h of t is the height in meters and t is the time in seconds after the stone is released. So we want to determine the time at which the stone will be at its maximum height, and we're going to round that to 2 decimal places. Then we want to determine the maximum height to the nearest meter, and then the time at which the stone will hit the ground. So to determine the time at which the stone will be at its maximum height, we want to find the vertex of this parabola. The vertex is going to be whenever t equals minus b over 2a. Or in this case, minus 10 over 2 times negative 4.9. And rounded to 2 decimal places, we get time is equal to 1.02 seconds. Now from part A, we know the time, 1.02 seconds. To determine the maximum height, we're just going to plug that into our function, 1.0. Rounded to the nearest meter, that'd be 105 meters. To determine the time when the stone hits the ground, we just need to solve the quadratic equation. H of t negative 4.9 t squared plus 10t plus 100. Using the quadratic formula, t equals negative 10 plus or minus the square root of b squared is 10 squared minus 4 times negative 4.9 times 100 divided by 2 times negative 4.9. Remember, the height of the stone when it reaches the ground would be 0. So we're solving this for when this is equal to 0. That's why we're using the quadratic equation. This is negative 10 plus or minus the square root 2060 divided by negative 9.8. This is negative 10 plus or minus 45.39 divided by negative 9.8, which will give you 2 times for t. Negative 3.61 and 5.65. Now, because time can't be negative, we can cross this one out. And the time when the stone will hit the ground will be 5.65 seconds.